Hey, Abby. So that we're in lesson 66 and 67. So let's look at the first problem here. So we're going to type the numerator in the top blank and the denominator in the bottom blank. But first we're going to get this problem over here. So we've got 1 over z minus 2 minus 3m over negative z plus 2. Okay, so we don't like to have this negative right here. I'm going to flip this by multiplying by -1 over -1. Okay, so 1 over z minus 2, and then this is going to become a negative 3m so this would be a negative minus a negative 3m over a z minus 2. So now they have the same denominator. So we have 1 minus a negative 3m is going to be plus 3m over z minus 2. So you kind of got to look for things like that to figure out how to make that work. And if you paid attention, you would see this is the opposite and this is the opposite. So multiplying by the opposite over the opposite is going to give you the answer you want to make it one denominator. So that's what we had to do here. So you're going to have 1 plus 3m over z minus 2. And that's correct. So let's look at the next one. It's going to be very similar, I do believe. So that's the pattern that we're looking for here. We've got 3x plus 7 over negative x minus 4 plus x minus 7 over x plus 4. These are opposites. These are opposites. So if I multiply this one by -1 over -1, all right, so that's going to take care of everything inside of here. So it's going to be a negative 3x minus 7 over x plus 4 plus x minus 7 over x plus 4. So because this is positive, it doesn't change anything in here. So we can combine like terms. So basically I can just do this, and then I can make this one denominator. Right? So negative 3x and a positive x is going to be a negative 2x. Negative 7 is minus 14 all over x plus 4. The denominator is positive, which is what we want. So that's what you would type here. You would say negative 2x minus 14 over x plus 4. And they're both correct. Next problem. You see how easy that is. Those are not hard. All right, so let's go to the next problem. All right, so we've got, let me copy this over. Copy, paste, make it a little bit bigger. Okay, so we've got 30 degrees here. So this is going to be a 60, 90, a 30, 60, 90 triangle. So in order to find our sides, we can do a couple of different things. We can either use similar triangles, or we can use sine, cosine, tangent. I think what I'm going to do is use sine. I think that's going to help me here. So I'm going to use, let's see, so toa, that's going to help me. So I've got 30 degrees here, and the adjacent, or I don't have any of these measurements. I do have the adjacent measure. So the adjacent measure is here. So that's going to be the cosine of 30 is going to be equal to the adjacent over the hypotenuse, which would be b. b is the hypotenuse. So now I can multiply both sides by h. So h times the cosine of 30 degrees is equal to 7. So now I can divide both sides by the cosine of 30. And that's going to give me the value of h. 7 divided by the cosine of 30. So that's what I'm going to do. Pull my calculator, and I'm going to find, all right, I'm going to say the cosine of 30, 7 divided by. So 7 divided by, and I got to find the cosine of 30 separately. So 30 cosine. 7 divided by the cosine of 30 is 8.08. That's not enough to bring that up. So h is going to be 8.08. All right, so now that I have 8.08 here, I can actually do my Pythagoras theorem. So that's going to be 8.08 squared is equal to a squared plus 7 squared. So a squared plus 49 is equal to 8.08 times 8.08, which is 65.29. All right, subtract 65.29. Ooh, I forgot the point. 65.29 minus 49. That's a squared is equal to 16.29. So a is equal to square root of 16.29. So let's see if that actually works. It may have rounded more than that. So a is square root of 16.29. B is 8.08. Neither one of them's right. Okay, try again. So maybe they rounded it closer to 8. And if that was the case, then this would be 4, because that would be the square root of 16 in there. So square root of 16 is 4. Let's try that. Nope. All right. So let me figure out how they did that. They didn't do it that way. So I bet you they used a similar triangle somehow. So if this is 60, then I can do 60, 30, and this is 1, 2 square root of 3. All right, so that would be 90, 30. So the 90, 30 side, and this is the original triangle. This is a similar triangle. So the 90, 30 side would be 7 over square root of 3. Then you've got the 30, 60 side, which on the original triangle is b, and on the similar triangle is 2. And then you've got the 60, 90 side, which is this one. So the original triangle, 60, 90 is a, and that would be 1. All right, so we have some values we can do. So 7 square root of 3 is equal to b over 2, and 7 over square root of 3 is equal to a over 1. So 7 is equal to square root of 3 times a, and 14 is equal to square root of 3 times b. So 14 divided by the square root of 3 is the value of b. and 7 divided by square root of 3 is the value of a. We know good and well we can't have a square root of 3 in the denominator, so we're going to multiply both sides, both the numerator and the denominator by that. So we end up with 14 times the square root of 3 over 3 is the value of b, and 7 times the square root of 3 over 3 is the value of a. All right, so let's try that for our solutions, see if that gives us the thing we're looking for here. So 7 times square root of 3 over 3. And then this one, 14 times square root of 3 over 3. That's what it was looking for. It was looking for you to use the similar triangles. I will bet you, though, that if we solve that, we'd be close to what we had before. So let's see if we can do that. I'm just curious at this point. So let's see. 3 square root times 14 equals divided by 3. 8.08. Look at that. We were right. It just wasn't in the right format. So this is the same thing that we had before for B. For this one right here, we said it was 8.08. So let's look at the other one. We've got 3 square root of times 7 equals divided by 3, which would have been the square root of 16 point whatever. So we were right, it just was not in the format that the system wanted it. So you could do it two ways. It's just all about formatting in the situation. They wanted the similar triangle format. Okay, next problem. Let's look at this one. We're gonna do another one of those where you multiply. So we've got 1 over x plus 3 minus 7a over negative x minus 3. Opposite, opposite. So we multiply this one by -1 because we want it to be positive. So then we have 1 over x plus 3 minus negative 7a over x plus 3. Negative, negative cancel each other out, so this becomes a positive. 1 plus 7a over x plus 3. It's going to be your solution. All right, there we go. These are more of the same. These are absolutely more of the same. So you're going to multiply everything here by -1 over -1, and then arrange it so that it's x plus 3. When you do that, then you can combine these terms into one solution, into one fraction. Okay, here's another similar triangle. I know these are difficult, so let's go and do this one. So we're going to do similar triangles on this. So that means we need to have our similar triangle. So I'm going to draw the similar triangle. And this is going to be our 60, and this is going to be our 30. So the way I remember it is that from the 30 to the 90-degree angle, 3 squared is 9. So we have to use the square root symbol. That reminds me of that. So I know to put the 3 there. And I know in it's just 1, 2, 3 all the way around. So the base is 1. And 2 times 3 is 6. 2 times 30 is 60. So the 2 goes here. And then that tells me how to do the 1, right? That tells me how to do the 1. So those are the things that remind me of where those numbers go on the 60, 30, 90 similar triangle. And we learned that in lesson 69, if you want to go back and look at that. Is it lesson 69? No, that's a different lesson. I think it's this lesson, actually, lesson 66. So my point is, the way I remember it is the square root of, the square of 3 is 9. Square root of 9 is 3, because this is 90 degrees right here, right? So the square of 9, square root of 9 is 3. So the square root, and then the square root of 9 is 3. just little things like that, that the way you think about it will help you remember what it looks like. And then 2 times 30 is 60, and then the only other number is 1. So it has to go here, right? 1, 2, 3. That's how I remember it. Now you can create your proportions because they are oriented the same way. So we're going to do the original, which is the original is one in the problem, and then the similar triangle. Okay. You could also say this is the problem triangle and the similar triangle. All right, so you've got a 60-90, you've got a 30-60, and you've got a 60-30. Those are your 3 sides, and this is the angle degree. So 60-90 is this one. So on the similar triangle, it's 1, and on the problem triangle, it's y. The 30-60 side, that's this one, from 30 to 60. On the similar, it's 2. I'll go ahead and fill this out. So that's the hypotenuse. So 60-30 would be 7 here. And then 60-30 here on the problem triangle would be x. That would be the height. Okay. All right, so I use the angle degrees to orient. You could also call that, base, hypotenuse, height, depending on, now that you have them oriented the same. The problem with that is sometimes they're not oriented the same way, and it's harder to see which one is the base and which one is the height, right? So I use the degree of measure because then it doesn't matter. I can always orient it correctly to my triangle. Now that we have our proportions set up, it's really easy to find. You have 7/2 is the only one that has both numbers. So then you just set that one equal to both of the other ones. And then you solve. So 7/1 is 7, 2 times y. So 7/2 is the value of y. So we go ahead and put that in here. 7/2. All right, so we'll find x. 7 times the square root of 3 is equal to 2x. Divide both sides by 2. 7 times the square root of 3/2 is the value of x. So we put that in here. 7 square root of 3/2. And that is correct. Okay, next problem. Okay, we have another one. And we're going to do it the same way. Let me erase all of this because our similar triangle is going to remain the same, so I don't have to redo it. So again, this is going to be your 60, 90, 30. So from 30, let's see, 60 to 90. So it's going to be 60 to 90 on the problem is x. 30 to 60 is 30 to 60 is y. And I did something wrong. I've got 30 to 60 is not 60-30. It should be 30-90. I knew which one it was, but still, I wrote it wrong. So from 30 to 90 is 5. Right now, so 60-90 is 1. 60-30, 30-60, whichever way you want to go, is 2. And 30-90 is square root of 3. Okay, so those are my proportions. These are the only two that have numbers. So 5 over square root of 3 is equal to x over 1. And 5 times square root of 3 is equal to y over 2. So I can solve those. I have 5 is equal to 3 times x. Divide by square root of 3. 5 over square root of 3 is equal to x. We know we can't do that, so square root of 3 over square root of 3 times 5 times square root of 3 over 3 is the value of x. Same thing over here. We have 5 times 2 is 10, square root of 3 over times y. That gives me 10 over square root of 3 equals y. We can't do that. We can't have a square root in the denominator. So 10 times the square root of 3 over 3 is the value of y. That's what we type in. Okay. fractions. We have, for x, we have 5 times square root of 3 over 3. And y is a fraction of 10 square root of 3 over 3. Easy peasy. All right, next one. Oh, now we're in lesson 67. Lesson 67 is so super fun. Let me see what it is about. I don't know, but I'm telling you that it's about really fun stuff. So it's about radical denominators. So radical denominators, basically, when you have a radical in the denominator, we don't want it. And when we know when it is just a radical, we multiply by the radical. But if you have a radical and an operation, you have a square root number and another number with an operation in between them, we have to do what's called conjugating to get rid of it. So I will show you how to do that in this first problem. All right, so let me roll this up. We don't need this anymore. So conjugation is when you change the sign in the middle here, and the radical always has to come second. So you might have to rearrange it. But then you change the sign here to its opposite. And it's either, if it's negative, you make it positive. If it's positive, you make it negative. So in order to get the radical out of this denominator, we're going to say 1 over negative 3 plus square root of 7 times negative 3 minus square root of 7. Negative 3 minus square root of 7. So this is multiplying by, it's the same value of the same value. So we're multiplying that fraction by the value of 1, right? Because it's the same value of the same value. So it doesn't change this value here because we're multiplying it by 1. It's just a different form of 1. So when we multiply, we're going to go straight across and we're going to multiply this term. We're going to distribute just like we normally would, right? So we've got 1 times this, which means it just equals what it is. That stays the exact same. That doesn't change. This is where it gets hard, however. So what I like to do is stacking method. So I'm going to take this first term and distribute it here. Basically what it looks like is this. We take this and we do this again. We just distributed that, right? From this one to this one. So we know what we're doing. So in the stacking method, I'm going to stack these up where they match, like the form of the number matches. So negative 3 times negative 3, we know that constants and whole numbers, coefficients, all of that, they come first and radicals come second in the proper format. So that's the way we're going to write them. This is going to be a whole number. It's going to be a positive 9, so that comes first. All right, so negative 3 times a negative, so it's going to be positive, square root of 7. We can't do anything with that. So we say positive 3 times the square root of 7. That's all we can do. Now we're going to distribute the second one. Square root of 7 times negative 3. We can't do anything with that except write them the way they are. It's now a negative because a positive times a negative, right? So negative 3 times the square root of 7. Now we're going to take positive square root of 7 times negative square root of 7. That's going to be a negative 7 because positive times negative is a negative. These cancel out. When you do these, the whole point of changing the sign is to make a positive and a negative number that are the same that have that square root in them. Then you can cancel it out. That is the point, to cancel that out and to leave you with a whole number. In this case, that whole number is 2. That would be your denominator. So it's not hard. You see, it's not typically hard. It's just that there's a lot of steps. So it's a little bit tedious in regards to, I got to do all the steps. But even that is not a whole lot of steps, right? It's not a whole lot of steps. These will cancel. You're going to be left with a whole number. If you're not left with a whole number, you need to check your work and see what happened. Maybe you didn't conjugate it correctly. Maybe you put the wrong sign in there. Maybe you skipped a step. Maybe you skipped a number. But if you split it like this, where you take this first one and distribute it to this one, and then the second one and distribute it to this one, it's a lot easier to see, and that's perfectly okay. So we should have here -3 minus square root of 7 over 2. And that's correct. So we're just going to keep doing that. What happens when you have 2? You do it the same way. All right, so let's roll this up. We have 5 over 3 square root of 2 plus square root of 3. So we change the sign on the radical because we want the radical to have an opposite. So that's what we're going to do. We're going to change the radical for both of these. I think. No, we're not. We just change it for the operation that's existing there. So it's going to be times 3 times the square root of 2 minus square root of 3. 3 square root of 2 minus square root of 3. Okay, so I multiply that. I get 15 times the square root of 2 minus 5 times the square root of 3. Now I'm going to distribute to find my numerator. So 3 times the square root of 2 times 3 times the square root of 2 minus the square root of 3 plus square root of 3 times 3 times the square root of 2 minus square root of 3. So let's find that. So 3 times square root of 2 is going to be 3 times 3 is 9, and then this would become a 2. So we have 9 times 2 is 18. And now I have 3 times the negative square root of 3. 3 times the square root of 2 times the negative square root of 3. So that's going to be a -3 times the square root of 6 because these two multiply. All right, now I'm done with that one. So now I'm going to go to square root of 3 here. So that's going to be the positive version of that. All right, +3 times square root of 2 times +3 is a +3 times square root of 6. And this is going to give me square root of 3 times square root of 3. This is a positive times a negative. So it's going to be 3, but it's going to be a -3. This cancels. And this becomes a +15. So that's my denominator, 15. Now, there is something that I see here in all of the coefficients. They can all be divided by 5. 15 divided by 5 is 3 times square root of 2. 5 divided by 5 is 1, so it's going to be minus the square root of 3. And again, 15 divided by 5 is 3. So this would be your fully reduced answer. So when you get your answer, look at the coefficients and see if they all have a common factor so you can reduce it. So we're going to check our work. So we have 3 square root of 2 minus square root of 3. And this would be 3. And that's correct. Same thing. All right, this one I want you to try by yourself first, and then press play. Press pause, do it by yourself, then press play and check your work, okay? So go ahead and pause. All right, so we should have conjugated by changing the operation to a negative. So then this is the same value over the same value, so times 1, right? I split the distribution, -4 times this, positive square root of 5 times this, right? So I split it up so that we could see what we're doing. And then I did each row with the stacking method. I said -4 times -4 is a +16. -4 times a negative square root of 5 is positive because negative from negative positive, right? So then when I did the other one, I got a -4 times square root of 5. And negative square root of 5, oh, I'm sorry, I'm here. Positive square root of 5 times negative square root of 5. That's going to be 5, but a positive times a negative is a negative, so that gives me -5. 16 minus 5 is 11. That's my denominator. So we're going to type that in. I have -8 minus 2 square root of 5 over 11. There we go. One of the things you also want to be careful of is if you end up with a negative number here, you put that negative number there, you can't have a negative denominator. So if you end up with a negative denominator, you've got to multiply by -1 over -1 because of the rules of fractions, because the denominator must always be positive. So pay attention to that as you're doing this also. You might have a problem come up where it gives you a negative here to make you remember that rule. Let's do the next problem. So again, press pause and do this one on your own. And then when you're done, press play to check your work. All right, you should have gotten 2 times the square root of 2 minus square root of 3 over 5. So this one was fairly easy because 1 times this, you just write it out right here. Makes it really easy to do those. And then you did 2 times square root of 2 times the denominator here, and then positive square root of 3 times the denominator over here. This times this gave you 8 because you have 2 times 2, and these two together make a 2. So 2 times 2 times 2 is 8. And then you would get 2 times square root of 2 times the negative square root of 3 gives you a -2 times square root of 6. This would give you the opposite, or a positive 2 times square root of 6. And then this would be square root of 3 times negative square root of 3 would be a -3. 8 minus 3 is 5. These two cancel out. So let's type that in, make sure we're right. 2 square root of 2 minus square root of 3 over 5. And we're right. Last one, yay! Let's scroll this up. These are not super hard. You should be having a little fun with these, or at least not be super stressed about them. They're not difficult math. It just looks difficult. It's just multiplication and addition and subtraction. It's not a lot to think about. So again, pause, do this one on your own, and when you're done, press play to check your work. All right, last one. So we had the problem was written in the wrong order, in the wrong format. So we had to rearrange that. So it's going to be -3 plus 3 times square root of 5. So if you did not get that from the very beginning, then stop and redo it. Like, look at your notes and see if that affected your answer. If your answer was not 1 plus square root of 5 over 6, then you need to go back and redo from the very beginning, because that could be very well be where you messed up. Now, if you caught that, then you would conjugate this positive into a negative and do -3 minus 3 times square root of 5 over -3 minus 3 square root of 5. So when we multiply that, we get 2 times -3 is -6, and 2 times -3 is again -6, but this time times square root of 5. So then we conjugate this, or we distribute this, not conjugate it. We're conjugating it as we distribute. So -3 times this denominator plus 3 times square root of 5 times this denominator. That's what we have here. So -3 is positive 9. And this is -3, -3. That's a positive 9 times square root of 5 right here. Then we have 3 times square root of 5 times a -3. That's a -9 times square root of positive 5, or square root of 5. And then positive 3 times a -3, that's a -9. And then we have square root of 5 times square root of 5. So it's -9 times 5. That's going to be a -45. That gives us a -36. Remember what I said a couple problems ago? If you have a negative denominator, we can't do that. So we multiply times a -1 over -1. Again, the value of 1. So it doesn't change the value of the problem, it just changed the form. That gave us 6 plus 6 times square root of 5 over 36. Looking at all of our whole numbers here, we see we have a factor of 6 they have in common. I divided everything by 6 to reduce it. to 1 plus square root of 5 over 6. So when I do that, I get 1 plus square root of 5 over 6. And those are correct. And I think that is your final problem. Oh, it's making me do it again because I messed up with the one we did before. And I think I still have that written down because I was using tangent and not the other way. Yeah, that's this one. So A was 7 square root of 3 over 3. And B was 14 square root of 3 over 3. Let's make me do another one again. I got that one right. All right. Type the numerator and the denominator. I already did that one. Where did I do it? I did it down here somewhere. Here it is. So that was 3 square root of 2 minus square root of 3 over 3. So what did I get wrong? Three times square root of 2 minus square root of 3 over 3. Did I get this wrong before and I didn't see it? All right, let's figure out what the answer should be and see why. Negative x plus 8. Oh, it's not the same problem. Hello. It's a different problem. I'm dumb. All right, done. What did I get for that problem? This one. So way before those. Hello. It's not one of those. Oh, that's Michaela's. Where did we do that problem? I know we did it. Did I erase it? Oh, you know what? I didn't do this one. This is the one I told you to do on your own. Okay. All right. I don't feel so dumb now. Let's just do it for the fun of it. So you can check your work. X plus 5 over x plus 3. And I'm going to multiply this by, got 2x minus 3 over negative x minus 3 times negative 1 over negative 1, which gives me x plus 5, x plus 3, plus negative 2x plus 3 over x plus 3. All right, so I've got an x and a negative 2x. It gives me a negative x. And then I have 5 plus 3 plus 8. Okay, that's shaping up to be right, x plus 3. All right, hello. Miss Tracy sometimes is nuts. Just, I don't know if you knew that or not. And then this is x plus 3. X plus 3. And now that's right. Okay, cool. I was thrown for a loop there. I forgot about that one. But now you have something to check your work against. Yay! So you can see if you got that one right or not. All right, and that should be, yeah, that's all of them. So that's lesson 66. Lesson 67. I'm going to send you another video for the last one for first semester, and you should be all done with first semester except for the semester exam. So I don't know if you turned that in or not. If you turned it in, I can't undo that. But if you haven't submitted it yet, I'll send you a video on what you need to finish in order to submit it, okay? So it's all about whether you've submitted it or not. If you haven't, don't wait for the video. If you have, I'm sorry. We'll have to pull up the grade in the second semester. Okay? All right, deal. Bet. All right, I will see you in the next video. Bye, sweetheart.